Hello and welcome to this special Engineering Outreach edition of the Art of Engineering podcast. I'm your host, Chad Harden, structural engineer with Michael Baker International in Irvine, California. You can visit us online at www.taepodcast.com. Well, I'm so excited to talk about engineering outreach on this episode, which is just in time for Engineering Week, February 21st through 27th, and introduce A Girl to Engineering Day, which is on February 25th. There's a lot of great resources online if you are looking to explore engineering outreach for education. I'll post two of those websites on the homepage, but the first is it's www.nbsp.org, and the second is discovere.org. This show explores the evolution of a career in engineering, and to help us talk about engineering outreach, I'd like to welcome Bethany Orozco with Encore STEM Teachers Program.
Thanks for having me, Jen.
Yes, thank you. And just want to give people your webpage too for your company. It's www.encore.org, spelled ENCORPS.org. And with that, I'd like to just welcome you. Thanks again for coming.
Yeah, thank you for having me.
So tell me a little bit about, first, I guess, what is your company involved in?
Yeah. So the Encore STEM Teachers Program is a nonprofit organization. We're California-wide. Okay. We actually work in 5 regions of California. In Southern California, we're in Orange County, San Diego, and the Los Angeles area. Okay. And in Northern California, we're in Sacramento and San Francisco. And essentially, we were founded in 2007 to take care of a big issue actually that we have in education and STEM education in particular, and that is the
STEM for those who don't know what STEM means.
Right, yeah. STEM is science, technology, engineering, and math. Okay. And so we have a huge teacher shortage in California. I mean, across the nation, but especially in California. And in addition to that, just underachievement in general in science and math and engineering in our schools. And so Encore transitions STEM professionals, anyone who has that type of industry background, into second careers as teachers. And we also get STEM industry people, kind of like yourself, involved in tutoring and mentoring students. So essentially, getting a real professional engineer in front of, let's say, a 9th grade student who might perhaps in the future consider that as a career path.
Great. How did you get involved with STEM and STEM outreach?
Yeah, well, I guess for me it kind of starts back in college, from Minnesota. Okay. So you might hear that in my voice. Okay. I've been in California for about 5 years, and I studied civil engineering actually. Okay. Halfway through, I decided physics was extremely difficult. Okay, right. And I switched to math with nice. Actuarial emphasis. Okay. So that was my background in college, but I was a tutor for the Minneapolis public schools in Minnesota. Okay. And worked with middle school students with their math homework, essentially, after school. And the Minneapolis public schools are somewhat like the Los Angeles school district. Lots of students are very behind in math and science. And so I saw that when I was working with them. I actually got recruited into an organization called Teach for America. Okay. And then became a math and science teacher in California. Oh, okay. So I worked in Hawthorne at a school called Da Vinci, which is a very much a school that's focused on engineering as well as science and math. So I was a teacher for a few years, and then I moved on to recruiting teachers. Okay. So that's kind of it's an intersection. Yeah. It's a weird intersection of like STEM and teaching and education. Right. Yeah. Interesting.
So why are students behind, say, specifically in math?
Oof. That's a big question. Okay. So it's actually kind of a hard thing to like put a finger on because there's so many reasons, and there's also probably people would argue about the reason why we're so behind. Okay. But I would say sort of our students don't get exposed to real world connections in science and math. at an early age very often. So many times students will, you'll be working on math and science. I don't know what your elementary or middle school years were like, but probably you didn't connect them to careers, right?
Right.
It was like, here's 2 + 2, and here's, what you can do with math and all of the rules, but not necessarily a real world connection. So that's a really big thing. Then, of course, there's just, in general, our low income and minority students are also farther behind than higher income students.
Okay. And
they just don't have access to the same types of opportunities, or really great teachers.
Okay.
They don't maybe meet a professional engineer ever.
Wow. Right.
So those are some big reasons. And I think, another is just that, like, we focus a lot in schools on testing and not a lot on necessarily challenging students to really think deeply and persevere through challenges, which is a huge thing in your career field.
Absolutely.
Right? Yeah. So that's a big issue in schools, but there's a lot of things that schools are doing that are innovative now as well. So I was just telling you, I was actually at the Project Lead the Way conference this past week, and this is just one example of some really cool stuff that's happening in schools now. Project Lead the Way is a curriculum that's used statewide. Schools have to sort of opt into it.
Okay.
But essentially they get students to focus on engineering specifically. They also have 2 other strands, computer science and biomedical.
Wow, okay.
Since we're talking engineering, I would love to tell you a little bit more about that.
Absolutely.
So it actually starts at the kindergarten level. And they kind of explore engineering design process. Okay. But I know a lot more about the high school level. So there are 4 years of engineering courses that students can take in high school. Okay. It starts with Intro to Engineering Design, and then it ends with a capstone project. Okay. And essentially, this type of curriculum is getting students really hands-on. Like, it almost looks like your old wood shop. Okay. These are what some of the classrooms look like. They've got woodshop tools, they've got 3D printing, they've got robots.
Oh my gosh.
They're doing all sorts of different types of engineering, and actually they have sort of specializations as well. So they might do aerospace, electrical, mechanical, and focus in on a different specialization.
And so a school as a whole would buy into that program.
Yeah, exactly.
Because I've heard a lot about certain schools doing such as an after-school program where they're building robots, which sounds really exciting. Yeah. But this is more of the whole school encompassing that.
Yeah, and I mean, those types of programs after school are also incredibly needed. Not every school can dedicate time and money and resources to having a full-on engineering program. But it is a way really for students to explore that as a career pathway. Okay. Also, not just Project Lead the Way, but these schools that are doing this type of curriculum, which is often called project-based curriculum, also expose their students to internships. So in 11th or 12th grade, they might actually go and intern with an engineering firm. They also do presentations of learning or exhibitions, which they might actually present to a panel of engineers. Right. And have to defend their work and whatnot. Nice. Yeah. Nice. So it's really, showing these students that this is a potential career pathway. Okay. And either you can pursue it and go on to, a 4-year university, or, there's so many jobs in STEM that you don't necessarily need a 4-year degree for, and can go and get employed right after high school as well.
In my experience, I definitely agree in internships, because the earlier the better, even if you're in college, say first year, second year, because you find out what you like and what you don't like, but also you can really learn a lot of great stuff. Yeah. I interned at a construction management company, it's Boutier Engineering in Tustin, and I learned so much about communication that really helps me today. So almost anything you do earlier the better. You learn so much.
Yeah, and you learn what you don't want to do, right? Do you host interns here at Michael Baker?
We do. Yeah. We do host. We have internships. Usually they're college level. Through their summer on their break. When they're available.
Yeah.
But I just got something from UC Irvine where they're hosting high school students to come to different companies.
Okay.
And great. I don't have the name of that, but I'll put it on the website as well after the podcast.
Definitely.
One question I had for that Project Lead the Way sounds really interesting. What are the similarities between the Common Core standards that are in school now versus Project Lead the Way? The similarities and differences.
Yeah. Well, I can't say like specifically. I've never taught the Project Lead the Way curriculum, but in general, the Common Core state standards and the science standards are also called Next Generation Science Standards.
Okay.
Essentially, they try to go deeper and teach students to really think, challenge them to think and problem solve. And, being a former math and science teacher, I used the old California state standards in my classroom, and they were very broad and not very deep. And although I did challenge my students to think in that way, mostly because I worked at a project-based school, I think that that's kind of the change from old standards to the new. And in doing curriculum like Project Lead the Way or just any, there's a lot of teachers actually, I know some in the Orange County area that are doing amazing engineering curriculum that they create on their own.
Right.
Some former engineers, which is really cool to see them in the classroom now. And that in general aligns with the standards because it's just, you're really getting students to take a problem, brainstorm about it, come up with an idea, maybe build a model, test it, make it better. And so many of our students these days they look at a problem, and if they get the wrong answer, that's it. They feel, I didn't do it right. But when students are sort of trained in the engineering design process, then they know that's not the final step. You have to go back and try again, try a different solution, brainstorm again, and just keep doing the cycle over and over.
I've done a couple engineering projects in my daughter's classrooms, and one of them that I did was having the students build a bridge on 2 Jell-O in little boxes.
Oh wow!
So just real small boxes filled with Jell-O, and the bridge was just a small plank of wood. So it was really doing the foundations. And what I thought was really cool about that was that I didn't really instruct them too much. Just a little bit like, your feet are like a foundation, so think about that in terms of. And in both classes, like first grade, fourth grade or so, they come up with all these ingenious ideas about it without really any training.
Yeah.
So I think keeping your mind open and thinking critically when you're challenged is really, it's there already. It's just being trained to kind of hone in on that a little bit.
Yeah. And, we want our students to come up with those new ideas because they are going to be our engineers of the future. So it's a great experience for them.
So how can engineers get involved, or not engineers only, but STEM professionals, anybody involved in science, technology, engineering, and math, right?
Yeah.
How can they get involved and do this engineering outreach in various ways?
Yeah. Well, there's many ways that they could do it. Lots of great organizations out there that are matching up STEM professionals with classroom experiences. Through our program specifically, essentially, you can come to our program and let us know that you're interested in getting involved with education. We kind of take you through like an application and interview process. But once you've joined Encore, we actually call our cohort of tutors and mentors our STEM expert tutors.
Okay.
And so essentially once you've joined Encore, we would put you through a training and an orientation and match you up with a school site or an after-school program. Geography is very important in this area. So we have, programs that are spread out geographically. And also different grade levels and different subjects, depending on your area of expertise. And then we match you up that way, and our STEM expert tutors can volunteer anywhere between 1 to 5 hours a week.
Okay.
And then if they want to take it to the next level, it's open to them to explore the career in teaching.
Okay.
So if that was an interest, we actually take our educators through professional development and training, support them with earning a California teaching credential.
Okay.
And then eventually job placement support as well.
Do you need a master's to get the credit? Because I've heard, I don't know too much about becoming a teacher, but I've heard like you actually need to get a master's in teaching, right? If you're going to go teach, or how does that work?
No, actually. So the really cool thing that for sort of STEM industry professionals is, there's essentially 2 types of ways to get a credential.
Okay.
You don't need a master's, you need a bachelor's degree.
Okay.
That's the baseline.
Okay.
But as a STEM industry person, there's a credential called CTE, which is Career and Technical Education.
Okay.
And what's great is there's a huge need for CTE right now.
Okay.
At the conference, actually had schools coming up to me. Do you know any CTE teachers?
Oh, really? Okay.
So CTE is a credential you can get if you've had 3 or more years of industry experience.
Oh, okay.
And they're actually industry sectors. So you could get, say, an engineering credential.
Okay.
Or a computer science credential.
Oh, nice.
Which is really cool. And then that allows you to teach engineering only.
Okay.
That's usually at the middle or high school level.
Okay.
But it's a quick process. It only takes 4 months to get that type of credential.
Okay.
And it's not too expensive either. So
the CTE option. Takes you to being able to teach in middle school.
Mm-hmm.
And is
or
it
high school.
Or high school. And is it engineering? An engineering related subject like math or science, or specifically engineering?
Specifically engineering.
Okay.
Yeah, so you'd be able, typically the industry sectors, they'll name different, like you'd have possibly engineering and architecture, engineering and construction.
Okay.
And so you would be able to teach anything within that industry sector.
Okay.
Yeah. It's kind of interesting that, at the high school level, they're calling courses engineering now.
Oh, wow. That's pretty amazing.
Actually, when I was teaching, my course was called engineering, although at that time it was chemistry and algebra 2.
Wow.
So it was a little different.
Yeah, I was lucky. I got wood shop, which was fun.
Yeah.
But I also got hand drafting, which I think kind of got me onto the path. And then I had more drafting in college for AutoCAD. And then when I started here, I've learned from so many great hand drafters, which is really an art form.
Yeah.
How thick is the pencil?
Right.
And nobody thinks about that anymore because everything's on the computer.
It's kind of a lost art.
It's a lost art. I feel like I'm always on the cusp of that technology that went away. But if you keep your mind open, there's really a lot to learn from these people that have all this experience from before computers were available.
Now, do you think that students should go through hand drafting before they learn the computer?
I think so.
Creative?
Absolutely.
Yeah.
If it's possible to keep that in the curriculum, because it forces you to think about what you're drawing. I mean, if you're doing it with your hand, I think it's a little bit, not that, I don't know, in 20 years, is that even a feasible thing to, I think you always have to be able to draw it by hand on paper.
Yeah.
And a lot of what we do on a daily basis is, at least in engineering, redlining plans and for the ultimate presentation.
Yeah.
So knowing how to present something on one piece of paper that's clear and concise and somebody can look at it and understand it, maybe even before you've talked to them on the phone. It's kind of an art form that takes a while to just to be able to communicate.
Yeah, I'm sure. I think we've seen some schools go towards computer-aided drafting before ever doing hand drafting.
Okay.
But the engineers that I speak to want to keep that tradition alive.
Yeah, definitely. Yeah. Now, you have another level of training that's not just the CTE program, but something that what does that next level entail, and what does that allow you to do?
So the single subject credential is a teaching credential in California that would allow you to teach classes like math and science as well.
Okay.
So, your traditional chemistry, biology, or math classes. That is a more traditional type of program where you would actually go back to the university and go to school for 12 24 months essentially.
Oh, wow.
To earn a California teaching credential in those areas. But as a single subject credential teacher, you actually cannot teach CTE courses.
Oh, interesting.
So
really?
You wouldn't be able to teach engineering and vice versa.
That's kind of fun. Why? Can you get a credential in both, or is it mutually exclusive?
Yeah, you can get a credential in both. What's interesting now is that a lot of single subject credentialed teachers want to get a CTE credential, but not necessarily can because they don't have the industry experience. So one is really geared towards industry professionals, and the other is geared more towards traditional teachers.
Can a traditional teacher work with you to get the CTE certificate?
If they have industry experience.
Okay.
Yeah.
Interesting.
Yeah.
A lot of avenues. No,
I know,
really cool.
And it's the thing about it in California, well, I'm sure in other states as well, it's confusing. Mm-hmm. And so to come from the industry sector into education, even if it's just wanting to mentor or tutor or become a teacher, a lot of times, people are looking to Encore for support. Because they just don't know how to navigate the waters.
Right.
And we have a lot of experience with that.
So engineers can become involved by just getting involved on a more of a volunteer basis to full career placement.
Right.
Depending on their interest.
Yeah.
But I think I've seen myself, just students really just seeing an engineer talking to somebody in a STEM field is just, sometimes there's like this eye-opening moment, and it's like they're really excited about it. It's really fun.
Yeah, that's true.
There were a couple questions that came to mind while you were talking. Maybe we can go back to is like low-income areas. How do STEM challenges differ between a low-income area versus, say, a mid-range area?
Yeah.
Is it the same problem, just a different scale, or different problems? And how do the STEM issues there?
Yeah, probably the same types of problems, but on a different scale. I think one of the biggest things is that in low-income areas and school sites, a lot of times it's really difficult to retain really good teachers. And that's just because sometimes it's a tougher environment to teach in, possibly might be less pay. And so there's just challenges to keeping good teachers and attracting good teachers to those areas. I would say that's probably the number one thing. That's because I know that teachers are the number one in school factor for how students perform. Not necessarily resources, books, computers, teachers.
Because that's the person they're seeing every day.
Right, and they see teachers for 8 hours a day.
Right.
And they might see teachers more than they see parents.
Right, that's true.
Yeah, so that's a big thing. But, of course, then there's resources like money, resources like iPads or computers or tablets that they might not have access to in lower income schools, and that's sometimes based on the tax money that goes to the school sites. We in California have improved that a bit, just based on the way we fund our schools, but that's still going to be an ongoing challenge. And then I think the other thing is, in a lower income area, if you just go and drive around, you're probably not going to see corporations like your company or like others where they can see access to engineers or access to internship opportunities and this type of thing. So there's many challenges.
So I'd say if you're an engineer or a STEM professional, there's a lot of other there's another way to get involved too is American Society of Civil Engineers usually has a local chapter, and I know they also have an engineering outreach program where you can volunteer your time to go to a low-income school, or one near you too. So whenever you're, however you want to get involved, just go and spend, 20 minutes with a classroom and answer what do kids think about engineering, what questions do they have, and it can really open up a good discussion. Yeah,
there's career days, there's judging, a fair or being a judge on a panel. Right. And those are maybe even one-time opportunities if they don't have a lot of time to commit. Right.
Well, let's see, more on the lighter side, I guess. Let's see, what is a favorite work of art or type of art that you enjoy in your own life?
Gosh, I think my favorite sort of type of art is photography. I can't say that I myself am a photographer by any means, but I picked that because I was recently at the Annenberg Space for Photography up in the Los Angeles area.
Okay.
And the exhibit was about evolution.
Oh. Nice.
It was amazing. The photographer essentially took photographs all over the world.
Okay.
And, you can't go back millions of years and take photographs, but
right.
He basically tried to show the story of evolution through these different photographs.
Okay.
It was just beautiful. I think that photography is an art that, some people have an eye and a talent for photography.
Right.
I also just love family photography as well.
Okay, yeah.
So I follow some people on Instagram and that type of thing.
And I'm probably jumping around a little bit, but why I'm asking about art is because also the STEAM movement. I forgot to mention that. So there's STEM, science, technology, engineering, and math. But then there's also kind of a companion movement of STEAM, which is incorporating art into those. So how do you see art overlapping with engineering or other technologies?
Yeah. Well, I think while I think that the STEM movement is incredibly important, I think that STEAM, incorporating the arts, makes a lot of sense because especially in classrooms, that is a way you access student creativity, you get students interested. And I think just in general, when there's the ability to incorporate art into math and science, it brings it to a new level and accesses students' brains in a different way.
Okay.
So I actually saw some incredible presentations by a preschool that's up in the Pasadena area talking about their STEAM and incorporating the arts.
Okay.
And they just, science goes with art a lot. It really does. So they would do these fun, cool projects for the young ones where, let's say, they were able to incorporate different colors into their, or they're able to actually create a product or create something. Let's say, the corporation Qualcomm, they have their Think a Bit lab, where they're really teaching students to program and do robotics. Nice. And to incorporate the and also to get female students interested, they actually programmed it was like a hat.
Okay.
That students, they designed this hat. A piece of the hat had to move.
Okay.
So that was the programming part. But then they had a fashion show.
Oh, nice.
So, cool. I do think that that's a way also that you incorporate women into, and it's not to say that stereotypical, that all women are into fashion, but that is maybe a way that we can get more girls interested in creativity, STEM by using the A.
I think the scientific process too of questioning, it's there, just when you're 5 years old, and that scientific method is a creative method where isolating one variable at a time, and I think kids do that naturally. For example, you're playing in a sandbox and you have some kind of water that's, when my kids were in preschool, they would have this water fountain and the water kind of goes everywhere, but the kids naturally want to create these natural channels of water in the sand, and then you experiment with, well, what if you have this route to go and this route to go, and it's kind of it's fun to watch a scientific process in action, but it's a creative process too.
It is.
So, very interesting. Let's see. I think actually those are all the questions I had.
Great. I have a question for you.
Oh, okay. All right.
How do you use sort of creativity and art in your daily work?
Yeah, thank you. Yeah, that's a good question. I'd have to say that for me, I feel most creative when I'm presented with this project with 20 variables or 10 variables. So say a bridge project where you have, maybe it's crossing over a channel and there's high water requirements, a maximum flood elevation, so that causes the ground to scour, and so that limits certain foundation types, and there's all kinds of variables that we have to consider. So for me, it's kind of eliminating those variables in a creative way that is also the most efficient, and then also trying to design in a way where I'm designing efficiently with my time. It's a big challenge to not spend double the time that I really need to and present all that information in a way that somebody else can look at it. I think for me that right now is the biggest creative thing that I enjoy.
Yeah. Was creativity sort of like encouraged in your education?
Definitely. I think we all have a teacher that we remember that really spurred, some sort of creativity. And I was lucky that I had a lot of teachers that were just really out of the box, I think. And the first one that comes to mind on that subject is Mr. Abernathy. He was in 5th grade, and we did this whole classroom project. It's funny kind of how your education shapes you a little bit, but we did the whole classroom project where we had a little miniature city, and we had these different projects of designing different vehicles or coming up with an idea for vehicles. So what kind of transportation system should we employ in this city that we're creating?
Sure.
And that was one of my tasks, and and this was in 5th grade, and we came up with flying cars, or a car that could change from flying to a boat or whatever, and doing a little model, and and then I think he had different challenges too. So depending on how you did in the class, and maybe it wasn't related to that, but a math test or a writing test, and you would get money that you could then use in the city, and so it was this year-long city that we were interacting with, and it was like Sim City, but we were building it for real, and that was pretty amazing. And actually, it's funny that you asked me that, and I didn't think about this, but so that's civil engineering in a sense, and that's essentially what I'm ending up doing. I'm a structural engineer, but you start out as a civil engineer, and so
specialize.
Yeah.
Would you say is that where you got your inspiration to, what inspired you to pursue engineering?
So in high school, so I'm going to hand the mic over to you now. I love these questions. That's great. In high school, I was strong in math and science, and I kind of wanted to do something good for the environment, which is not where I ended up, which is fine for those of you in high school. Think about what you want to do. But I wanted to do something that I could maybe impact the world with in some way. And so I actually went into environmental engineering. But then I got to, organic chemistry, which is in college, it's like this 8-hour lab for weeks on end. And I liked chemistry, but not that much. So so that was within the larger civil engineering umbrella at UC Irvine. And I switched over to civil engineering, and it really was the perfect choice for me. I really enjoyed the transportation engineering and structural engineering, and I ended up going into the master's program there, and I actually couldn't decide. So I was either, and so what I would say is try and intern early and find out what you enjoy, which I did, and it kind of helped shape my direction in that way. But I also took some graduate classes while I was an undergrad, and then again that really showed me how exciting maybe even higher education is. So I took some of the transportation planning courses, which was really exciting, and I also took some structural courses, which was also really cool. And actually they're very similar problems. So a big transportation network has certain if you have a lot of traffic, it's kind of like an obstruction, right? Or we call it a stiffness, and in structures a stiffer member causes other things to happen in a structure. So they're actually very similar problems at a very basic level.
Interesting.
And I actually couldn't decide. I don't know how I did. I don't know how I did decide, because I had some really great teachers there too. But something was telling me structural engineering. So I did that, and I've loved it ever since.
That's great.
I don't know if I answered the question very well, though.
I think you did.
Okay. I guess just follow what you enjoy. But if there's also other ways that technology can be involved in your life, and that could be things from video editing to if you're more on the creative side, there's still ways to kind of bridge the gap between arts and engineering. So a lot of fields out there that could be very exciting. Yeah,
especially these days with social media and being, let's say, a software engineer or things like that.
Right.
And I think one of the coolest, I watched a documentary about coding, women in coding.
Girls who code.
And it was like the woman who codes for Pinterest or Facebook. These things. Right. I'm like, wow, that actually could be a really fun career.
That would be fun.
Yeah.
Well, thank you, Bethany. I think this was really fun, and thanks for all the questions, too. That was fun. So.
You're welcome. Wanted to learn about you as well.
Well, thanks. Well, again, if you're an engineer or anybody in the STEM profession, Engineering Week is February 21st through 27th. So find a school, spend 20 minutes, and open the door for some kids who might not have thought otherwise about engineering. Yeah. And February 25th, introduce a girl to Engineering Day. Thanks again.
Thank you.
Thank you for listening to The Art of Engineering. You can visit us online at www.taepodcast.com. Music for this podcast was made available with a Creative Commons license by Bensound. Music title Sunny at bensound.com.